Okay, hello everybody. Today we're going to be doing Pygame, and we're going to be making Snake. So I'll go ahead and give this a run here. Here we are. So this is what we're going to be doing. It's a classic game of Snake. I think this is probably one of the most common things that people build in Pygame, just because Pygame is, of course, the little snake guy, and Python is the snake. I'm really not sure. So all you're doing here, you need to go and collect the fruit, and I just lost. So we're going to go and collect the fruit. In our case, it's going to be cherries. So the two ways to lose are going to be hitting the tail of your snake or hitting the edge of the window. And as you collect a cherry, your score goes up and your tail gets longer, so the game gets harder. In our case, we're going to be running at, let's see here, we're running at 120 frames a second, and we're moving, let's see, I think it's 30. Dun, 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 dun. Here we go. We're moving every 20 frames. So at 120 frames a second, 120 divided by 20 would be 6. So we're moving every 1/6 of a second. So that is kind of where we stand. So every 1/6 of a second, you're going to be moving, and it just gets harder. So we're going to start by importing Pygame, just so we can use the library. We also need to make sure that we initialize it. So we'll say pygame.init, init, to initialize Pygame, warm it up, get it ready to go. And then we'll go ahead and just set up the, let's see, we'll set caption here. We're going to go ahead and set up the name of it. So I call it Snake Game. Let me go ahead and scroll in here for you guys so you can look at it a little bit better. Okay, the next thing we need to do is we need to set up the actual screen here. So it's pygame.display.setMode this time, setting our size of, let's roll with 500 by 500. Now, if you're using the images I'm using, it is important that you use a multiple of 50. We're going to be moving by 50. I'm moving by the width and height of my block. My snake here, right here, is a square, right? So it's got the same length as it has width, or height as it has width, I suppose. And it's 50 by 50. So every time we move, we want to give the almost illusion of it being a grid. So we need to move by the width and height of our image. So in this case, my image is 50, so my screen has to be a multiple of 50. It could be 550, could be anything, right? In this case, I'm using 500. That way you can move a total of 10 from left to right, or 10 from up and down. Okay. We also need to set up our event loop. I always like to do this as a function because I feel like it can get big, and I really just don't like having it in my main game loop. So just to start off, we'll say for event in pygame.event.get, and a colon on the end of that. And then inside of this, we'll say if the event's type, so event.type, is equal to pygame.quit in all caps, then we're going to call the pygame.quit. So just as a little refresher, every frame, check the events. If you hit the X button on the top right, we're going to close it out. We'll also go ahead and check if the, we'll do that later. I was going to say, we'll check for an escape button to leave, or we'll do that later. Okay, the next thing we're going to do is set up our main game loop. So in this case, we'll just do while true for now. And we're going to check, we're just going to call our event loop. We're going to go ahead and fill the screen with black. So screen.fill, and the color we're doing is 0 red, 0 blue, 0 green, 0 red, 0 green, 0 blue, sorry. And finally, we'll go ahead and flip our display. So pygame.display.flip. On its own, this will run, so we get this nice little snake game. Okay, so we've set up our, we've imported Pygame here, we've initialized it, we've set our display up, given it a name, set up the screen, everything's running all handy dandy, of course. Oh, it wants me to put a space after these, so it is interesting how, yeah, it is interesting how PyCharm yells at me. Okay, let's go ahead and begin with the snake now. Now, if you've done this with me before, I like to create classes for everything, and I think that's what a lot of people do in PyCharm. I always like to keep them as different scripts. So we're going to be making a new one here. I'll go ahead and create a new file, and I'll call this snake.py. Now, I'm doing this in all lowercase because the class is going to be in uppercase S. So, of course, we need to import Pygame off of this, and we just need to do what we can to get it up and running right off the bat. So class is snake, boom, okay. And we're going to define the initialization function. it is going to take a screen as well. And I did not mean to hit M there. There we are. It's going to take the screen as well. Now from here, we're going to set up a few variables. X is equal to, we'll set it to 50 to begin with. We'll set the Y value equal to 0 to begin with. We will set the speed. Now this is where you put whatever the length and width of your square is. So for me, it's 50. We'll go ahead and set up the image now as well. This is stored inside of my images folder. So image equals, and now I'm going to say pygame.image.load. I'm going to load the file name. So images / and I called it snake with a capital S.png. And you'll notice in PyCharm at least, when you go ahead and type that, it does tell me it's 50 by 50, so I'm good to go. Next line, I'll set up the rectangle as well. So self.rect equals self.image.getRect. Now you'll notice I have set up an X and a Y here. These are going to be updated at the end when we try to draw to our screen. We're going to update our rectangle with that information. We only do that because it makes it easier later on to calculate different things with the position. Okay. So let's also go ahead and define the blit function. I always call this blitme. And all this function does is set it to the screen. So first we update the rectangle, so self.rect.x and its y value. Self.rect.y is equal to self.x and self.y. If you guys have not done this before, all it's going to do, it's a one-line way of doing this. The other way would be to put a semicolon. It would be something like self.rect.x equals self.x and a semicolon there. Self.rect.y equals self.y. I personally find this to be a little more convoluted and uncomfortable to do, so instead I do it like this. The first value is assigned to the first value, the second value is assigned to the second value. Fairly simple. Okay, let's also go ahead and blit to the screen now. So self.screen.blit. We need to give it the image, so that'd be our self.image, and the position, which is that rectangle. Let's go ahead and hop back to main. We're going to say from snake, import that snake class we've made. We'll go ahead and create a player on line 10. Just call it player, and it's equal to snake. Snake with a capital S, my bad. Now you remember it takes the screen here, so we'll pass in our screen. We've called it screen here. Now just because we called it screen here, that doesn't mean that it's asking for a word named screen. If we called this guy XYZ, I would need to call this XYZ. It's simply saying that it needs some screen to render upon. We happen to have called that variable screen. Finally, inside of our event loop, after we fill, we need to make sure to display our player onto the screen. So player.blitme will pass or suffice with that. Okay, snake has no attribute screen. It seems to have had a bit of an issue. Oh, we forgot to save the screen as an actual variable. There is no self.screen. So on line 11, I'll say self.screen equals that screen variable we pass in. Okay, let's go ahead and give this a run now. Boom, and there we are. So that's great. That looks pretty similar to our start. I'll run the start again. Give me one moment. And there we are. It looks pretty similar to our start, so we're already off to a good start here. Now the next thing we need to do is set up basic direction for our block. Now to set up direction, we also need to set up input. Luckily, our event loop can handle this. We're going to check for the event.type to be pygame.get or .keydown, I'm sorry. So if it's a key down event, right, if we push down on the keyboard, we need to know to set the direction. Now to set the snake's direction, it needs to have a variable to handle that direction. So in here, we'll go ahead and set another variable. We'll do it right under screen, actually. We'll say self.dir is equal to, and we'll start off with 1x and 0y. That's what starts us off at the beginning with moving to the right one. Okay. Now in here, all we're going to do is check if event.key is equal to pygame.k underscore, and the first one we'll check for is the W key. Now I'm using WASD. On my GitHub, you'll see I also have the arrow keys put into place. If you want to see how to use the arrow keys, you can put those in. But ultimately, all you do is instead of k underscore W, you would use k underscore up like that, and so on, right? Right is right, left is left, and so on. Okay, so the W key is going to be an up value, right? So we're going to set our direction, our snake's direction, to 0, -1. Remember, going upwards in Pygame is actually subtracting from the y. So we're not going to say self here because we're not inside of the snake class. Instead, we're going to use our snake, which happens to be inside of a variable called player. Player.dir is equal to, we'll set it to 0, -1 because we want to go up. We're going to check if the event key, I'm going to go ahead and copy and paste this. We want to check if the event key here is we'll do S next. In this case, The dir will be a positive y, so 0, comma 1. Check if the event key, we'll do a next. Check if a player.dir, and this one will be equal to a -1x and a 0y. Finally, we'll go ahead and check the d value, and in this case, it'll be the direction is equal to a +1 and 0y. So that's working great. It's setting our direction, but we're not doing anything with it yet. So inside of our snake class, we'll go ahead and set up a movement variable as well, or a movement function. So we'll call this one move_me. Notice the underscore I'm using just to keep things nice and uniform. Blip_me also has an underscore, so we want to keep everything written very similarly. Okay, now inside of our move_me function here, all we want to do is update our x and y values based on our direction. So self.x is equal to, self.x plus equals, and then we'll use our dir, and to get our x value, it'll be the first item in the list. And self.y plus equals our direction again, and to get our y value, it'll be the second item in the list, which in this case is 1. Now this is a small issue. You'll remember our direction is adding by 1. But we need our things to move by more than 1. We want them to move at least 50 at a time. So here's where we multiply by self.speed to make sure that everything is moving in that grid type of form here. So we're multiplying both of these by speed. You'll notice that we're adding by x and y here, even though we never want to move in a diagonal way. And that's because y or x is going to be equal to 0, but we don't know which one. So this way, they both get added to, and anything multiplied by 0 is always 0. Finally, let's make sure we actually update the move_me here. So inside of our event loop, right before we blit, we're going to go ahead and call that move_me. And there we are. Let's go ahead and give this puppy a run, and it's gone. So notice it's moving really, really fast. If we got rid of this multiplication really quick, let's get rid of that speed. And you'll notice it doesn't move as fast, but it's gone. So you can see it kind of there for a second, and whoosh, it's gone, right? It's moving really fast. And that's because it's running at a pretty high FPS. The first thing we want to do is limit our FPS here. I like to put this after the event loop because I kind of care about getting the events first, but ultimately it doesn't matter. Let's go ahead and throw it at the top. We're going to call pygame.time.clock. Notice this is a capital C. This is a class. We're basically initializing a new class and saying, okay, tick, and here we need to give it a frame rate. Again, we're using 120 here. Inside of snake now, we're going to keep track of how many frames it's been since our snake has last moved. Now to do that, we'll need to set up a variable to hold that value, self.frames. I'll set this equal to 0 by default. Now all we're going to do is every time this gets called, we're going to add 1 to frames, and then check a quick if statement. If self.frames is greater than or equal to 20, whoa, there we go. And this is just in case maybe some kind of fluke happens and somehow our game, even though clock.tick should stop it, if our game goes over 120 somehow and we end up to 30 frames, we don't want to run into any problems, so a greater than or equal to sign. We're going to do this. We also need to reset self.frames back to 0. Okay, let's go ahead and give it a run now, and hopefully everything's running nice and smoothly. And it is, and you'll notice that when I hit the keys, I'm moving around the screen. This is a very snake-like formation, and it's working great. Okay, now it's time that we set up the icky part. We want to set up the tail of the snake. Now to do that, we need to find a way to delay the way that the tail moves. You'll notice that if an item in our, let's see, let me open up Paint for a moment. There we are. I don't have any better program than Paint. Okay, geez, that's white. Okay, so if I have a snake here, here's his little head. He's a very cool little snake. And then here's his body. Now, when this snake here decides to turn downwards, so he's moving down, the body's going to move to the last location first and then update. You'll notice that while the head moves in real time, the head moves immediately. We'll call this the 0th frame. The item in the first place is going to move 1 frame later. The next one, this item is in the second place, is going to move 2 frames later. We need some way to delay that. Now, a lot of beginner programmers will start with, oh, well, maybe I can hold all these things in a list. And I'm sure that could work, but that would be wildly inefficient. Instead, we're going to set up something called nodes. Now, classes have the ability of holding variables within them, including other classes. Our snake has everything we need it to have to be able to run the individual body pieces without really making too many modifications. All we're going to do is start with our head. And you'll notice the head is linked to the next body piece. It's also linked to the one after that, but only through this piece. If this piece somehow got cut off from the snake, maybe it got in some sort of fight or something, and whoosh, that piece is gone, the head is no longer linked to it. What this means is we have something called linked nodes. They look like this. Here's my head linked to this next node, and that node is linked to this one, and so on. You'll notice this node in the back does have a link, but there's nothing here for it to link to. So its link is known as a none variable. We will be using this as well. So all we're going to do is say, okay, I've moved. Now I'm going to pass my last direction off to this guy. And once this guy moves, he's going to pass his direction off to this guy. So we'll need to store a variable to hold on to the direction of the last frame as well. But after that, it's pretty simple. Think of our link as sort of a pipeline, and every time we move, we're sending off the direction we used in the last frame to the last guy. That way they make sure to go where we were right before we've moved. When our head moves down, our head says, hey, right before I moved down, I was right here. Passes that data off to here. This guy moves then to the right, because that's where the head was, and says, okay, I just moved to the right. Before I moved to the right, I was right here. And it passes that information off, and so on. Let's go ahead and head back to our code and begin with this. Now you'll remember we're setting these up as nodes. Now you don't need to call these nodes. I'm going to. So I'm going to say self.nextNode. And it's equal to none by default, because by default, the head of our snake does not have any nodes attached to it. Our head is on its own. We also need to set up a variable to hold on to our last direction. So we'll call it lastdir. And we don't want to start this off at none. We'll go ahead and start it off at the original dir value. And that's because even if a user hits any button at all right off the bat, they're still going to start at that first position. Okay. Now when we move our snake here, right before, we'll do it right here on line 24. So after we've moved our snake, we've reset frames to make sure that nothing bad happens. We're first going to check if self.nextNode is not equal to none. Basically, do we have a node to do things to? If we have a node to do actions with, we're then going to set its dir, self.nextNode.dir, equal to self.lastdir. Finally, self.lastDirection is equal to self.direction. So here's what we're doing. We add a frame every frame. Once we've reached at least 20 frames, we're going to move our head and reset frames. If a node exists, let's go ahead and pass our last direction onto that node's current direction. Basically saying, hey, now you need to move to where I was last frame. And finally, reset our last direction to the current direction. Because now, where we're at now is going to be what we use next frame to tell that last node. Awesome. We will hop back to our main here, and we hit run. You'll notice everything still works just fine. But we have no way of adding new nodes. Now we do have things we can do about this. Let's go ahead and add a node manually. We'll go ahead and call this one just B. B for body, maybe. And it's equal to snake, screen. And let's go ahead and set its x value, so b.x. We'll set that x value to 0. That way it's right behind our snake. And then finally we'll say player.nextNode is equal to b. We've set b up as a snake. We've set the x value of it so it's not right on top of our snake. And then set the node. And you'll notice now our tail, oh, it didn't show up. Oh, we're not blitting it. Oh my goodness. We have to make sure to actually update it down here. b.blitme. Okay. Let's go ahead and give this a run now. And there it is. Now it's still not quite moving with us. And that's because we haven't fully set it up yet. Inside of our snake, you'll notice that we're updating the position of it, but we're not telling it to update anybody else, right? So we're going to add one more function. We're going to call this one moveBody. And all this is going to do is run through and tell each body to move itself, display itself to the screen, and then make sure that we set up the next one to do the same. So we're going to start by saying body part is equal to self.nextNode. we're going to say while body part is not equal to none. Basically, while there is another body part. So in this case, we're starting at the head. Oh boy, this is ugly. Okay, so in this case, we're starting at the head right here and saying, okay, look for a tail. Do we have another piece to go to? We do. Let's go ahead and tell it to move. So inside of our body part while loop here, we're going to first tell it to move. So body part dot move me. Then we're going to tell it to blit. Body part, geez Louise, dot blit me. And finally, let's go ahead and set up our body part for the next loop. Body part equals body part dot next node. If our current body part, let's say this piece, does not have another node, you'll notice this one does not, then our while loop will kick us out. Variable and function should be lowercase. Oh, okay, just being funky. Okay, now inside of main, instead of doing all this fun stuff, let's just tell it to move the body. We'll just say player dot move body and give it another run. You'll notice now that our snake body moves along with us. And if we add another, let's go ahead and add another node to it. I'll just rename all the B's here as C. Whoops, C, I missed a dot there. And I don't want this one to be on top of the last one, so we'll call it negative 50x. And give it a run. You'll notice it actually works pretty nice. Uh-oh, looks like we ran into a little bit of an issue. Oh, that's why. We set it to, let's set that to B's next node. There we are. And here we go. So it seems to be working pretty swell. The only thing is, this is really inefficient. Let's create, whoop, and it's gone. Let's go ahead and pop these guys out. We don't need these anymore. We're going to create a function in our snake to add on a new piece. Because when we collect a cherry, our cherry needs to be able to very easily add a tail on. So we'll create another function here, and I called this one, let's see, I called this one new node. So we'll call it new node. Oopsies, there we go. Okay. And I like to give this one a title. It's going to create a new node at the tail end of the snake. Okay. So we're going to first off start by creating a variable calling it cur node, our current node, and it's equal to the self. We're going to say while the current node dot next node is not equal to none. We're just going to update the cur node equal to cur node dot next node. Okay, that's weird, right? It's a lot of weird variables. Basically, start off with our head. While the current thing we're looking at has a next node, right? The next node's not equal to none, so it has a piece after it. Update it and go to the next piece, because we're looking for the last one. Let's go ahead and take a look at this in here. Pop rid of all these. Okay, so here's one node. It links to this one. That links to this one. Now our while loop says start right here. Okay. Then it says, let's look for the next one. It says, we start up here, and then our while loop says, while the next node exists. So we look over, do we have a node? We do. Sweet. Go ahead and go to this one now. Does this one have another node? It does. Awesome. Go ahead and go to this one now. Does this one have another node? It does not. Okay, stay right here. This is the tail of our snake, because there is nothing that comes after it. Awesome. Now that we have the tail of our snake, we can create a new thing. And here I'll create a little comment, and I'll just say, we've found the end. Create a new tail. Okay. So I'll call this new node for now, and it's equal to a version of the snake. And we do need to give it the screen. I just went ahead and grabbed the current node's screen, so that could be the tail. It's all the same. You could use the self if you wanted to. It really doesn't matter. Self.screen or current node.screen, they both work. They use the same screen. Let's make sure we put it in the correct x and y value. New node.x, we're going to set that equal to the current node's x value plus our speed, so that'll be kernode.speed times negative kernode.dir 0. The y value works very, very similarly. Only difference is we make sure we use the y values here, and within our direction use the y value in the direction. Finally, our current node's next node is equal to the new one we've created. Okay, let's look through this for a minute and kind of think about how this works. Our new node is equal to a new instance of our snake class. That should be pretty self-explanatory. We've done that before. update the x position equal to our current node's x position plus whatever our speed is times the opposite of the direction. Let's take a look at that. What does that mean? Okay, we want it to show up at the very end of our snake. So let's just assume we're starting with the head here. We have no tails. This is the head of our snake. And we want to create a new node. Our snake is moving in this direction. That means that a tail needs to show up in the opposite direction. Our tail should not show up here. It should not show up down here. And it should certainly not show up in front of the snake. It needs to show up in the very back of it. And that makes sense. But the problem arises when our snake is facing downward. Let's say you've moved down. You have 3 nodes, you've moved down. So our snake is facing downwards like this. It has another node here. It has another node here. And you want to create a tail right here. Now we're creating a tail here because this is the direction of our current snake. We do not want to create a node here because our player never went there. And if we created one there, that would be really jarring. Instead, the way that snake works is we're basically going to be creating one right at the end. And then you'll see some people like to make it so it'll wait for the next move. So you've collected a cherry, it waits to move, and then actually just plops it right here. Instead, we're actually plopping it right at the end, and if I remember correctly, it updates so fast that you won't even notice it gets longer at the end. It just looks like the back sits there for a minute, which is how a lot of the games end up looking anyways, regardless of how you code it, so it doesn't matter. So all we're doing, we're taking our current direction arrow. So in this case, our current node would be the one on the very end, which is where we want it to be. It's going to grab that arrow, flip it around, whoosh, this direction, and say, oh, well, that's where I need to place it. Wherever that points, right there. Now we're multiplying it by 50 because if we are starting here, we need to go along. Let me get a different color. If we're starting right here, we need to go along as far as our width is. That way we don't have any overlap. And there's our x position. The y value works the same. Let's say your node was moving downward. All it's going to do is flip it this way and put it there. Okay, cool. So that works great. And then finally, we make sure to create that link, right? So what's these? I can't undo. There we go. Okay. So let's say you've created this, right? We've got our nodes here. Boom, 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 boom. And you'll notice this one has created one. It's already, remember, it always has that link, but you haven't linked to the node. Right now, it thinks it doesn't have another node after it. So we're getting rid of that X and saying, hey, here's your new tail. And this guy now creates its own link of none. Awesome. So now that we have this whole new node thing after that big ugly block of code, we should be able to just call player.newNode. Or next node? New node. New node. There we go. Next node is a variable. New node is a function. And boom! There it is. Now this is cool because let's just play around for a minute. We'll make a quick for loop. For underscore in range, we'll maybe add 5 pieces onto the end and tell it to create 5 new nodes. And here's our snake. It looks great. Now, one of the things I did find interesting is when you go off the screen, sometimes it seems to run into problems. And like by that, I mean sometimes when you go off the screen, you'll lose one of your nodes. Now, I'm not really sure why, but ultimately it doesn't matter because when you go off the screen, we're going to stop it. You will see some newer snake games wrap your snake, so when I go off on the left, I'll come back on the right. I just found that really disoriented and ended up not doing it. But here's our snake. Now it looks really, really good. And we can play around with it a bit more. Oh, whoopsies. There we go. We can play around with it a bit more. Maybe I set that to 15. 15 is a really big snake, but here we go. Now it's a snake with 15 pieces on the end. Ultimately, this is pretty much all we need for our snake game. Now all we have to do, we have a means of creating a new snake. We simply need to create the actual cherry power-up and call the new node when the cherry gets picked up. Well, that's great. Let's go ahead and create a new script. In Pygame, I'm just going to go to File, New, make a new file. I'm going to call this one cherry.py. Again, make sure, cherry, there we go. Make sure you do a lowercase because the class is going to be an uppercase letter. So we're going to start by importing Pygame. We're then going to create the class of cherry. And inside of my images folder, I do have a cherry.png. So again, hop onto my GitHub, grab the image there. This one is also 50 by 50. It does not take up the full 50 by 50. However, it will make sure that it's centered properly. Since everything else is 50 by 50, it just works great. If you're going to create images for your snake game, make sure everything is the same resolution. Okay, awesome. Let me zoom in. There we go. So we have our carry class, and we're going to start again by just our basic Pygame stuff. We're going to define the init function. Oop, and there we go. And again, we do need the screen for our carry. We'll set up the image. Self.image is equal to, this is pygame.image.load. We're going to grab our images folder, / and then carry.png. Go ahead and create the rectangle as well. Self.rect is equal to self.image.get the rectangle. So create the rectangle around our image. We'll go ahead and create the x and y values like we did last time. Self.x, I'm starting mine at 200, 200. Self.y equals 200. I just find that to be a decent spot to start the first carry. We can always randomize it if we wanted to, but ultimately it doesn't matter. Finally, self.screen is equal to the screen that gets passed in. Let's go ahead and create the blit function as well. Blit me, and self.screen.blit, self.image to the rectangle. I'm noticing I did forget to update the rectangle. So again, self.rect.x, self.rect.y is equal to self.x, self.y. Update our rectangle's x position to our new y position. Our rectangle's x position to our current x position, our rectangle's y position to our current y position. Now again, we could be using just a simple self.x, self.y here, but we're going to end up using the sides of it later, so we keep it as is for now. Okay, let's go ahead and import our carry here. From carry, import our carry. Go ahead and create the carry. So here I called it power up. So I'll say power up is equal to, it's going to be our carry class with the screen passed in. And then down here, I like to blit the carry on top of the player. So I always just say carry.blit me. You probably won't even notice it. Now in here you will. Name carry is not defined. Interesting. Where? Name carry is not defined. Oh, because it's not called carry, it's called power up. Sorry guys, thank you. Okay, we hit run, and there we are. Now that looks great, and that's why I like to blit it on top. For testing purposes, it makes it easier. Now we're not actually going to let the snake eat it. Instead, we're just going to move it to a location that the snake is not. One of the issues you'll run into when you just let it randomize its location is it'll go sometimes onto places where the tail of the snake is, and we'll start with that and then make it so we can kind of restrict where it goes. So inside of our carry, we're going to make a new function and call it eatMe. And in this time, we're going to go ahead and retrieve the player as a parameter. So we know who's going to be eating. Now, by the player, I don't mean the full snake, just the head. The player should not be able to hit the carry with the tail, but if they somehow do, the tail cannot eat something. So all we're checking is if the x position of, is if the x position of our carry is equal to the player's x position, and the y position of our carry is equal to the player's y position. Now this is actually the furthest we have to go, because everything's on a grid, so there are a total of, I think, 100 locations possible. There will not be some situation where they have two different x and y values but are still colliding, because they're all on the same grid. So, for example, if I had 10 positions, let's say x values between 1 and 10, and I place my carry to x5, if my snake is at x4 or x6, there's no possible way for it to go there. It's not going to be touching it. The only possible way for it to grab the carry is if it has the same x and y position, and that's how it looks visually as well. So this is perfect. We don't actually need to do any real collision testing. Let's just check to see if they have the same x and y values. If they do, first we'll go ahead and add a new node onto our player. So in this case, let me double check. We did call it, okay, we did. Cool. I'm just making sure. It was new _ node, my bad. Okay, so we're adding on a new tail. Now we need to go ahead and create a new position for our snake. So new position is equal to a random.randint. Now, one of the issues we're going to run into is we can't use random without importing it. So on line 2, let's go ahead and import the random library. And we're randomly selecting between 0 and 9. This is because we don't want to, our grid is 10 by 10, but if you place it at x position, y position 500, 500, it'll be off the screen. Because 500, 500 is the very top, or very bottom right. But the position of our carry is the top left, so it'll put it just off the screen. You won't be able to see it. So our x value is the 0 through 9 times 50, which is just happens to be the width and height of our snake. And again, for our y value, random.randint 0, 9 times 50. That way we pick a random thing here. Okay, self.x is equal to the self.x and self.y is equal to the new position. This will automatically pick just like it did last time. Now, new position here is a tuple. However, it has two values. Self.x will pick the first one. Self.y will pick the second one because of the order we've placed them in. Finally, we're going to return true. Now, we're returning true because when we eat, we're going to be adding 1 to score. So we'll return true for now. We'll use that value later because we need to add 1 to score, and the only way to do that is to return back to our main so we know that something has happened. Let's make sure we call powerup.eatMe here and give that guy a run. Oh, we forgot to pass it to the player. Good news is that's pretty simple. Alrighty, so now every time we touch it, you'll notice our snake gets longer and our cherry moves to a new position. And I'm sure if we play long enough, we'll run into a situation where it spawns on the tail. I really don't want to sit for too long. It is kind of fun though, so if any of you decide to play long enough, you'll notice there's nothing stopping this. Whoa, whoopsies! There's nothing stopping the cherry from spawning on the snake's tail. It is kind of a low chance for a while because, as I said, there's 100 total positions that it could spawn. And right now my snake takes up, I think, 7. There it is, boom, right? It only takes up a few positions. Now we want to stop that from happening. Because although it's not a big deal right now, later on in the game, let's say you're trying to... oh, there we go. See how I went off screen and my node got messed up? So later on, when you're trying to reach the very end of the game, you could run into some issues where as the cherry spawns, I don't know where my head is anymore. There it is. There we are. As the cherry starts to spawn on top of your tail, it's going to be impossible to get it. We only want it to spawn in open locations. This is actually pretty simple, but we need the help of our snake class. Let's create a new function within our snake class, and we're going to call it getPositions. So create a new function here, call it getPositions. And inside of here, we're going to start by creating a position list. We're going to start by saying that node is equal to node. There we go, is equal to self.nextNode. And all we're going to say is while node is not equal to none. So if here we are. Oh, and none should be capital N. There we go. Okay. So node is equal to self.nextNode. So while node doesn't equal none, all we're going to do is say, node starts at self. We want to start with the head, right? So self, and then while our node exists, because if we go to self.nextNode and we don't actually have another one, then we want to stop trying to grab its position because it doesn't exist. Self.nextNode still exists, it just has a value of none when there is no further nodes possible. All we're going to do is append the x and y positions, so node.x, node.y, and then pass our node on to the next node. So node is equal to node.nextNode. So update our node to be the one next to it. If we're in the middle part of our body, so in this case again, if we're, let's say we're right here, we've gotten that position, move on to the next one, and check this one's values, update its x and y, and so on. Finally, let's go ahead and return the position back to whoever called it. Now inside of cherry, all we're going to do in here is before we update our x and y values, we want to create a simple while loop. While new position is inside of player.getPositions. Basically, if our new position is equal to one of the values that gets returned by that getPositions function, we're going to make sure that we recalculate it. So just go ahead and copy and paste this line right here, line 15 for me. Because we're just going to recalculate it. This is probably not the greatest way of doing this. You could run into some issues later, especially if your snake beats the game and you don't have a win condition in. We won't be making a win condition this time. I challenge that up to you. There will be one on my GitHub, so if you can't figure it out, check out my GitHub. But if you don't have a win condition and you're filling up all 100 spaces, one of two things happens. Either your snake will run into itself and you will lose with a score of 100, Or you run into an infinite loop and your game freezes because it's constantly trying to find a new position that doesn't exist. But on its own, this works great. So I'll run it. You'll notice our game works just fine. It runs. I'm not going to try and prove this to you, because the only way to prove it to you would be to either play this for a very, very long time or to win the game. So instead, what we're going to do is you're just going to have to take my word on it and play around with it later, and notice that the cherry never runs into the snake's tail. It never spawns on top of the snake. Read the code. You'll probably end up believing me, or you won't. Who knows? Okay. Oops, I forgot to delete that. Okay. Next, let's go ahead and create the lose condition for the snake. We want to make sure that the snake is able to lose in two cases: if it runs off the screen or if it runs into its own tail. So in this case, we're going to create a function and call it check loss. So I'll put it right here under get positions. DEF, I call it check loss. Okay. Now there are a total of 2 conditions. We're going to write 3, but that's because they have to be written 3 different ways, and I'll show you how. The first one is simply checking if we hit our own tail. So if self.x, self.y is equal to one of the get positions places. Well, here comes a little problem. Our head's position is within the get positions, so when we grab all of our positions, our head is one of those positions. So you'll instantly lose because your head is exactly where your head is, and that's a problem. Now we could create a new function, or instead, we'll just create a new parameter for this and call it include head. And by default, that's true. Now instead, we'll go ahead and pass a false value here. Because we've set a default value, we do not need to update cherry, because if we don't give a value here, it'll automatically assume that we want to include the head. Let's create a simple if statement. If include head, here we are. Go ahead and start off with the head node. Otherwise, node will be the next one after, so self.next node. Okay. Now inside of our check loss, we're simply going to return true. Our main function will handle losing, so we don't need to worry about that. Next, let's check our x values. If the x value of our snake is less than 0, or the x value of our snake is greater than our screen's right side value. So in this case, it's 500, but we'll make it in case you want to scale the game. So self.screen.get the rectangle of the screen and grab its right side. And if either of these are true, let's go ahead and return true. And that's too many spaces. There we are. And finally, if the y value is self.y is less than 0, so if we've gone above the top of the screen, or self.y is greater to or equal than, let's make sure this is an equal sign as well, greater than or equal to. There we are. Self.screen.getRect.bottom. And again, return true. Now you'll notice we're using the greater than or equal to signs for the second operation here and not the first one. That's because 0 is a valid number. 0 will put you on the very top left. 500, on the other hand, is not. 500 will put you off the screen. So it is kind of weird. You'll get used to how those positions work in Pygame. Hopefully you're kind of used to that now if you're doing Snake, but who knows, right? Okay, this works great. Inside of main, we'll go ahead and call this function. So all we're going to do in main is say if player.checkLoss. Let's go ahead and quit our game. So pygame.quit. Now this will give you an error because it's going to quit the game and still try to flip it afterwards, which is interesting. So if I run off, you'll notice I actually do get an error right here, display surface quit. But it doesn't matter because it won't really affect any of our players. So, oh well. Now there are other ways to do this. Another way would be to, instead of using a while true loop here, setting up a variable and simply setting that variable to false, and then at the end telling it to quit. And that's a pretty smooth way of quitting. But it doesn't really matter, so I won't be doing that. Okay, let's go ahead and set up our score now. Now our score is going to be displayed using text, so we'll go ahead and warm up our font here. So we do need to call pygame.font.init. I like to call that right under our original initialization function. Then we'll set up the font. I'll set it up right here under the cherry in the player. I'm going to call it the score font, and it's equal to pygame.font.sysfont. Now, as far as I can tell, there are not a lot of fonts by default. I always use Comic Sans MS. Why? Because I don't publish any of my games, and I use 30-point font. Let's go ahead and create a variable to hold on to the score as well. Now you'll remember when we set up our, inside of cherry, when we set up our eat me function, it returns a true value whenever it gets eaten. So all we're going to do is run our eat me within a if statement. If that, so if player or powerup.eatme, then let's go ahead and add 1 to score. Finally, let's go ahead and render our text within score, or to display it. So all we're going to say here is score text. I'll call it a little bit better than that, is equal to point font, or not point font, sorry, score font. I called it point font in my little guide on the side that I made. Point font dot render, and I'm going to be using an f string here just so we can really easily add variables to it. Score, let's go ahead and use our score number, and then a comma. Let's not use anti-alias here, and let's set the color. I'm using white. Awesome. Let's also go ahead and blit it to the screen now. So screen.blitz, our surface here, we're not using an image, we're using a surface, but that works still. It's going to be our score text. And I'm displaying it at 20x 30y. And this should be a tuple, actually, not a list. It doesn't really matter, but a tuple uses a bit less memory. So I'll go ahead and use a tuple. Alrighty. I'll go ahead and add those spaces in, so Pygame quits yelling at me, and there we are. And that is about it for our snake game. So our snake can run around the screen and collect cherries. If it runs off, it'll die, and you shouldn't really run into too many issues here. Let's see, you do here's a little interesting thing. You probably saw that for a minute. So you can't run into your own tail, but if you swap places with it, like I did just then, there, it looks like you do. So that's just an issue of how we're displaying stuff. It's perfectly fine mathematically. The tail moves at the same time the head moves in, so you end up with this whoosh, instant thing that looks like you're hitting your tail, but you're not. So if you wanted to be really, really rude about it, I'm sure you could keep track of where that node is, that next node would be if it was there, and not allow that to be an okay value, but ultimately it works. But that's about it for our snake. So thank you guys. Like I said, check out the GitHub for any images, code, anything else. Check me out on Twitter. Follow me on Twitter. If you have any questions, anything like that. Thanks, guys. Bye.